Hey, now I want to share with you one of my favorite geometric theorems. It's really, really cool. It's called the polygon angle sum theorem. And it says that the sum of the interior angle measures of a convex, that means no indentations, polygon with n sides is given by n minus 2 all times 180 degrees. And this is so cool because it seems like, how can that possibly be true? Just no matter what the number of sides are, as long as we know the thing is convex. Like, here's a crazy thing. How many sides does it have? 1, 2, 3, 4, 5, 6, 7. Septagon. So now, how do I know how many angles there are, the sum of the interior angles? Now, where are the interior angles? The interior angles, of course, are the ones on the inside. So it's this, and then this one, and then this one here, and this one here, and this one here, this one way over here, and they might all be different. But if you take the measure of each of those and add them all together, it turns out that no matter how you draw this, if it has 7 sides, it's always going to have the same sum of angles, namely 7 minus 2, which is 5, so 5 times 180 degrees. Now, why is that true? Well, let me show you the idea, because it's so cool. It just involves triangles. Now, remember that the total sum of the measures of the interior angles of a triangle is 180 degrees. If we remember that, then we're home free, because look what I can do. I can take this picture and cut it up into a bunch of triangles. And how many triangles do I have? 1, 2, 3, 4, 5. And notice 5 is 2 less than 7, the number of sides I have. Well, if each of the angles in each triangle, the sum of those angles is 180 degrees, then what's the total sum measure of all the angles? It'll be 180 plus 180 plus 180 plus 180 plus 180, which is 5 times 180, which is exactly what the theorem asserts. That's actually the idea of the proof of the theorem. It's really that easy. It just hinges on the fact that we know the sum of the angles of triangles. So that's really, really cool. Now, let's look at an example. Suppose I look at a hexagon. So a hexagon, we know, has 6 sides. So if I draw one, 6 sides. Not making it regular, but I am making it convex. And now I want to know the sum of the angles. No matter how I've drawn it, what's the answer going to be? Well, I see that I have 6 sides, and so I have 6 minus 2 times 180 degrees. And what does that equal? Well, that equals 4 times 180 degrees, which equals 720 degrees. So the total sum of all those angles is 720 degrees. Really, really, really cool. So let's take a look at some examples together and see this happening live. So let's find the sum of the interior angle measures of a convex hexagon. Well, that's what we just did, in fact. So you already know the answer to that. That's 720 degrees. So that's pretty good. How about this one? Find the measure of each interior angle of a regular octagon. Okay, now this is a different question. You see, what makes it different? Each. The theorem tells us about the sum of all of them, and now I want to know the measure of a particular one. But I am actually happily and luckily given one extra piece of information. It's regular. Remember what regular means? It means that all the angle measures are the same on the interior angles, and all the sides have the same length. So in fact, this is a very, very, very special octagon. It's not just, in fact, you know what kind of octagon it is? It's the kind that we see in red usually, which I'm going to try to draw live. This is always not good, by the way. All right, here I go. A stop sign. How can I not draw a stop sign? There we go. That's not perfectly right, but you get the idea. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 8 sides, and all the angles are the same. Hey, if all the angles are the same, then I know if I can find the sum of all of the angles, all I have to do is divide by the total number of angles I have, which are, of course, 8. So I'll use the theorem to find the total sum of the angles, and then since I know all the angles are equal, I'll just take that answer and divide by 8. So what do? If we work this through, what I see here is I use the theorem. I have 8 sides. I subtract 2, and I have 180 degrees as a multiple here. And so I see 6 times 180 degrees. And now, to actually get the answer that we want, that's the total sum, I have to divide this by 8. So if I divide by 8, that's going to tell me what each individual angle is. And so now, let's see if we can now simplify a little bit. And so if we simplify this, we get down to just 3 times 45 degrees, which equals 135 degrees. So that means that each angle here, right here, has a measure 135 degrees. Really neat. So notice how we went in a regular polygon, we went from knowing the sum of all the angles to actually knowing the measure of one angle by dividing by the number of sides, which is the same as the number of angles. Really cool. All right, let's take a look at an even more exotic example. This one has a little bit more of an algebraic flair. And so now here is the question. The question is, I'm given this quadrilateral, okay? So it's PQRS. And what I want us to figure out is the measure of all the different angles, knowing that, in fact, this is called x, and this has the same measure, x, and this has a measure of 4x, and this has the same measure, 4x. How could I possibly do that? All those x's are running around in our heads. But relax, because we know what the sum of all those angles is by this wonderful theorem. How many sides do we have here? 1, 2, 3, 4. It's a quadrilateral. And so I know I've got 4 sides. And so what does that mean? It means that I can figure out the sum of all the angles. Well, the sum of all the angles would be 4 minus 2, which would be 2. 2 times 180 is 360. So in fact, the sum of all the measures is 360. But I know each individual measure, and I can add them up. It's x plus 4x, that's 5x, plus x is 6x, plus 4x is 10x. And I can now solve this equation for x by dividing both sides by 10 to isolate the x. And if I do that, I see that x equals 36. So this is 36 degrees. And this is 36 degrees. But what's this? Well, this is 4 times 36, which is 144 degrees. And this is 144 degrees. So we were able to even figure out individual angles for polygons, even when, in fact, they're not regular, as long as we know some relationship among the angles. In this case, how the angles are related by this x, x, 4x, and 4x. Very cool. Very, very cool. Great.